Hey, how you doing? This is Jnani, and we are group 4, and we are today I'm here to present content based image retrieval project. This is our mini project. We are a group, as I mentioned, we are a group, and we are a three in a group, and myself was Jnaneshwar and Satvik and Mahesh, and we are three as a group mates, and we three has been did all together of the project, and we three combined and all did all together. And this was background information of our project. This was the problem what we are solving, and what was important of problem, and we had been rectified some problems, and we do what are the importance of the by this project, what we can do with the project, what we can solve. And we did some of the key values and key problems we have solved in this. First one, developing a system search retriever image from the large database. You can visual a content with the from the large database, which was uh which was impossible with the human. So we can do with this project content based image. And our goal was implement simple efficient to get implement for everyone very easily and very efficiently. And this was our goal to get for every access to every one of this project. And the important of this project was scalability. Scalability was facilities which we have which we are focusing, and the images and the uh, failure, not non failure of the images and all the stuff. So taking if you, for example, if you take social media, medical database, or etc, some of science scientist databases of science database. So if you take it, gonna be vast of data. So we collecting of the data, and we have to be sorting out. It gonna be very challenging. By this project, it's gonna be easier for everyone, and getting a grayscale image and converting the images and sorting the images. It's gonna be very easy with this project. And accuracy comes was overcomes the limitation of the text based search. The accuracy was it we are climbing that accuracy was high by this project, which was getting from a large uh, getting from a sorting from a large scale data, what we want. For example, thousand of a, if the database contain 1,000, so we can sort with 20, and you can analyze that 20. It's gonna be simple for you and easier to analyze it. But they comparing traditional way of 1,000 gonna be uh large amount, you take it takes large time. And foundation, provide the fundamental building blocks for modern visual and technology search. We implemented some small which we use code and all the stuff, uh modern visual technology, which include in the MATLAB, and we used to that for sorting. And next, go to literature review. For literature review, we had some, let's look briefly what other have done in this field. Researchers typically classify futures into two main groups. One was global future, and second was local future. And let's look into global future. And let's they describes entire image. For example, are colors, histogram, overall texture, or the shape of the objects. Global features are fast to compute and simplify to store. Simply to store, what we can do, the global feature which they had been introduced, easy to store, which was accurate data. After the implementing, you can easily store. And however, for they can be sensitive in the background changes. For instance, if you take the same object, put it in against a different background, the global feature may change significantly. This is what the global feature was climbing. Briefly I was saying some briefly. And so for global feature, and coming to a local feature, sorry, they describe specific key points or regions in the images. Example, include shift and surf descriptions. These are much more robust to transformation, scattering, rotation, and oscillation. However, they require more computational power, and are slower to compute. So in a local, they're slower to compute, and the accuracy might be somewhat differ, and that's what they climbed. And in our project, which with the global future, specifically a color histogram, because it's simple, efficient, and good starting point for the learning the basics of uh, content based image retrieval project. So we use like global future because like as a beginners we are focusing of like simple which going into a step by step, so we focused on a global future. And coming to methods and the methodology, we use like first like we use like couple of steps. And in the steps, like first step was like future extraction. Our project like works on a several steps, as I mentioned. First is future extraction. We represent each image by computing a normalized 6-bit histogram. That means that we compress the color information into fewer bits and making it manageable in a size, and then normalize the histogram so that features are size invariant. Normalization is very important because it ensures the two images which the same color distribution but different resolution are still treated as similar. So at the end of the step, every image in the database repeated as numerical feature vector. So that's all. Like it was like step one, and this was the methodology we use. And like step two, like watch coming to a second step, similarity computation. Next we need a way to compress that feature vectors. We use uh, excluded distance as our simplicity measure. The idea is simple. Like each histogram is a point in a multi-dimensional space. The smaller the distance between 2 points, that more similar the two images are. So for a given query image, we compute its distance to every image in the database. That gives us a list of distance or for each image. Like coming This was like second method. And like coming to a third method, which was like ranking and retrieval. Once we all have all the distance, we sort them in ascending order. The closest image, meaning that the one which was the smallest distance to the query, are considered at the most visual similarity. We then return the top result, typically like top 20 images, which we did in our project. Like our implementation, the query is displayed at the top of the result window. That like top 20 retrieved image are shown in the grid layout. Below it's in a rank order. So that's what like our steps which we included in our project, and these are the steps. And like this was the flow chart which I just briefed it. And coming to like key implementations for our one was like we implement the system in MATLAB. The process includes that reading the query image, the database image, computing feature for all images, storing distance, and ranked result in a MATLAB mat file. That called like uh, that the extension was like .m, which was we used in the MATLAB. And display the result in the figure window. And the final output is also saved as a PNG for documentation, or if you want to extract as a PDF, you can extract. Like there are like couple of options for extraction of your output. It gonna be depends on you what you want. And by structuring our code the way, we make the system modular and easy to extract later. So if you want to save your like your file or your code, that you can save in a MATLAB drive, so that you can access to like every time, like whenever you want, you can access easily. Go like quick go log into MATLAB, which online or offline, you can log into your MATLAB, go into MATLAB drive, and you can extract like a couple of times, like whenever you want it to use. So these are like the extensions we use, like RGB26CC, which was like our before project. We implemented that code into this. Like that was like a assignment, which like that's assignment for the extraction to this project, and we linked up. And like git hist counts and distance measure. And this was our project, and this was our result, which was like our result was shown like which we discussed. Like it pop up of 20 images in a grid layout. That what we did. We give an output, like for example, like some of the number like 101 or like 102 JPG or something. So we extracted it. So by extracting that, the output, some of the random output like random 20, that you can analyze it lot. It's gonna be the grid images. grid layout format. You can extract from this, and you can use for your like whatever you want, like for some research purpose, like for something you can use it from here. So this was our result, like it was a sample result, so I can show you like our demonstration like end of this video, so you can watch and you can see it, you can enjoy it. So like coming to a conclusion, excuse me, and the conclusion was like what we learned, like the conclusion is itself like what we learned. So we successfully built a functional like content based project, which we call like CBIR, system based on a normalized 6-bit color histogram for implementing for like getting like random pictures like into like grid layout format. So we implemented that. We learned that normalization is critical to ensure fairness between images of different size. We also learned that while color histogram are effective, they are not enough to fulfill capture symmetric similarities, so which we had noticed between by the normalization. And this project gave us practical experience in building a retrieval pipeline, and also showed us the challenging in bridging the symmetric gap. So this was like we learned in our project, and the future improvements, like the future work which we can focus on this project, like which we had like lot of opportunity in this project like to expand. So we had like integrating multiple feature, combining color with the texture of shape features could make it retrieval results more meaningful. Better distance metrics instead of Euclidean distance, we could try metrics like earth movers distance, which consider the cost of transforming one distribution into another. Local feature, like which we use like global feature, we can convert to local feature, which was like somewhat difficult, but you can implement, you can get like more accurate result, I guess. Using like method like shift would make like system more robust or to scaling, rotation, and practical abstraction. Machine learning, we can use machine learning in a MATLAB with the. In future we could also explore deep learning based feature, or like neural network or deep learning, so we can extract like LLMs and all the stuff into MATLAB, and we can use that, and it's going to be like more simpler, more simplified, and more easier for future works. And coming to references we use, like these are the references we use. Our references were like swimming, and second was as for Datta, and some of the random references which you can see over here. We taken like these references, and now we are jumping up into like our project demonstration. So like as I mentioned, this was our output, so I'm gonna print it again. And so which I said like this was our drive which I said before. This will be our drive, and this was our project, and the data we used stored import data, and we stored all our input images over here, and the source code is what we had run, the code like which we had run, like all the codes was here, like which we saved in a, like I mentioned, like you can save in a drive, so that's what we can save over here. This was the like codes, the scripts we wrote, and this was like you can see like result PDF or the .fig. This was like output you can extract in a PDF, or if you want you can extract in a figure. It was depends on you. And yeah, and now going into the project which we did. So this was our project. So as I said before, RGB 66, which was did with like 6-bit project before. In an assignment, this was our project, and we did over here. And check db was like, it used to check like dbmat, and like dbmat is a meta file, so it's gonna use for getting output. So it the db mat gonna be checked